Hello. So today we are doing this problem called Linkedlist cycle. So let's see what the problem says. So we get a linked list and we just want to determine if there is a cycle or not. So to represent this linked list, basically, or the cycle in it, here in the example, they are just giving us position. So we know which that represent the zero indexed in the linked list, so that the tails basically connect to that position and it's zero indexed, which means here, for example, the position is 1, which means 0 and 1 is 2, and then the tail points to that, so the tail points to 2. So this is a cycle here, as you can see. Same thing here, 1, 2, and position that the tail points to is 0, so we have a cycle here. Here, just one node, we don't have a cycle. And then a follow-up is using O1 constant memory. So we are going to try a couple of solutions. One of them is uses extra memory, but the others don't. So let's get into it. So the first solution that we can do is just use a hash map, basically. So let's take this example here. Something like this. So what we can do is just, so if we have, like, say, this linked list, and we have -4, I don't know, how can I present this? So let's say it's like this. Okay, so let's say this one. Well, let's just look at the example drawing here. That would be easier. So here we have this drawing. So basically what we can do is take a hash map, and then every time we encounter a node, put it in the map, and keep traversing the linked list. If you ever encounter a node that is already in the map, that means there is a cycle, because otherwise, if it was linear and there is no cycle, you would not encounter a reference to a node that is already in the map. And so as soon as we encounter that, we can just return true. And so that's exactly what we are going to do. So let's try this. So we need a map for the nodes. And then that would be like this. And we need to keep traversing the list, the linked list. And so if we find the node that is in the nodes map, then we can just return true, right? There is a cycle. And as we traverse, we just put the node, and we can just put anything as value. Let's just put true. And then we go to the next node. And so we keep traversing here and adding each new node to the map. But as soon as we encounter a node that was already there, then we can just return true. If at the end we traversed the entire list and head became nil, and we didn't find this condition, that means there is no cycle, so we can just return false. Okay, let's run this. Okay, so this one passes. Let's try another solution, which is usually called Hare and Tortoise, or just using a slow and fast pointer. So basically, the idea behind this is that we can have a pointer pointing to the first node. So let's see, let's take, so we can have something like this. We have 3, 2, 0, -4. So what we can do is have a pointer, a slow one and a fast one. The fast one basically jumps 2 nodes ahead. So if there is no cycle, then since the fast one jumps 2 steps ahead of slow, then basically fast will reach the end before slow, and they will never encounter each other. But if ever, if there is a cycle, then slow will keep going, and at some point they will encounter each other. And so that basically, as whenever slow is at the same position as fast, that means we have a cycle, because otherwise it's impossible that they did. And so we can just have slow and fast, and we can have So let's point slow to head, and let's point fast, as we said, to the 2-step ahead. So that means head that next, that next. And basically our condition is basically while fast is different than slow. And also we want to, so if fast reaches the end, that means there is no cycle. So we need to check that. So while fast, and that. And just to avoid like having, so what we are going to do is slow goes just 1 step each time, but fast goes 2 steps. So that would mean that next, that next. But to avoid having a nil pointer exception when we access this fast that next, we need also to check this. And at the end, we can just return whether slow is equal to fast. Because we are doing this, we don't know, maybe it's the last point node that kind of has the loop. So we need to still check here. And also maybe we did exit because of this is equal. So that means that's the result. So we don't know which one caused us to exit the while loop. So we just check if they are equal. That means that we have a loop. Even if it's both are nil and they are equal, that means that there is a loop, because otherwise slow would never have had catch up with fast. And just to avoid also having a nil pointer exception for this one, we can check if not head or not head next. So this is the case, then just return false. Okay, let's submit this. Okay, so that's solution passes. Now the other solution that we can do is, so if we have a linked list like this and reverse it. So if we reverse it, if it doesn't have a loop and we reverse it, that means that the tail of the previous linked list would be the head of the reversed one. But if it has a loop, then even if we reverse, because of this loop here, the head would be the same. And so we can just reverse the linked list. Basically, let me take an example, the simplest example, which is 1 to 2 and 2 points to 1, like this. So if we reverse this one here, what would happen is that we would have 1 points to 2, 2 actually points to 1, and then we reverse this here, that would be also like this. So the head would still be 1. But if we didn't have this and we reverse it, then the new head of the reversed list would be 2. So yeah, so that's basically the idea behind this solution. And so we could just reverse and then check if the head is still the same. If it is, then we have a cycle. And so let's define a reverse of head. And I have another video for reversing a linked list, so you can check that out, but I'm just going to write it quickly here. So we need to keep track of 3 pointers, the previous one, and the next one, and the current one. So basically we need previous so that it can we can point current to it, because that's reversing the link. And then we need to next so that we can point, for the next iteration, we can point next to this current here. And so let's just say this is head, this is none, and this is none. And we can do next. So we just keep track of this, because we are going to change current next to be prev, to be the previous value. That's what reversing the linked list is. And to do that, we still need next so that we continue the next iteration. And so we just keep it here in a variable so that we can assign it afterwards by doing current equal to next. So this is basically for the next iteration. Also for the next iteration, the new value needs to point to this current so that we can also reverse that links. So basically we need prev to be current. And at the end, it returns prev. And the logic here is just we want to check if head is equal to the reverse of head, that means that we have a cycle basically. If the head of the linked list and of its reverse is the same, that means we have a cycle. We just have to here handle a couple of cases. So, for example, for a linked list that is just one, then the reverse is also one, and so the head would be the same. But this doesn't mean that it has a cycle. Same thing for null, right? If we reverse this, would just get null too, and then so at that point, the head would be still the same, right? Even though we are comparing the references here and not the values. And so we can just return, check if head is not none and the head is not, that next is not none. Basically, that it's not just one node. Okay, let's look at this. Okay, so that passes. And those are the three solutions to this problem. Two of them are constant space, and one of them is not. So yeah, that's it for now. See you next time. Bye.